Now let's look at how we graph a variation of a secant or a cosecant graph. We want to graph y equals 2 the cosecant of 2x. Now typically the best way to do that, or a clever way to do that, is recognize that cosecants are reciprocals of the sine. So if we're able to graph the reciprocal function first, then maybe we'll be able to play off of that and graph our original function. So how do we graph 2 sine of 2x? Well, if we remember and we go back into our memory, we have an amplitude of 2. We have a period since it is shrunk by a factor of 2. So a full period runs a pi. I have a maximum there and a minimum there. So this graph, and then I can go ahead and likewise all right, not too even, but I'll take it. All right, that's the graph of y equals sine of 2x. Now off of that graph, we can start to build our reciprocal functions. Notice everywhere it crosses the x-axis, that's where we have a vertical asymptote at. So I can just go ahead and draw those guys in. Once I drew those vertical asymptotes in, then I can just start to draw the reciprocal components of the function. So this graph is going to come down vertically, asymptotically, approach those two. Here I got a bowl that's going to drop water. Over here I have the graph. And likewise down here. So it's just a matter of drawing the reciprocal function first, sine or cosine, which we're a little bit more familiar with. Then from there, draw the reflections or the reciprocals of that particular graph to get the cosecant in this particular case. You all right with that? You need to stop, rewind, play? And let's figure out how we can graph a secant function or variation of a secant function. So to remember what reciprocal identity a secant is, if you do, let's graph that one, and that's a cosine. So let's graph the cosine, or negative 3 cosine of x squared. First of all, remember we need to determine what its period is. Its period is this value of b. 2 pi divided by the value, which is 1/2. Solve that particular value, that equals 4 pi. So I have a full period going over a distance of 4 pi. From there, we knew there was 5 segments that we wanted to look at, or 4 segments with 5 points, so we divide that by 4. And we get pi, so every pi is a key point. And so forth. So every time one of those, something important is happening. From there, we can graph our graph. We know that it starts off at 0 is our first point. Cosine of 0 is 0. The cosine of x is 0. X is 1/2 is 1. 1 times negative 3 is negative 3. Sorry, cosine of 0 is 1. Sine of 0 is 0. First point, cosine of pi halves is 0. Cosine of 2 pi, 2, which is cosine of pi, which is a 3. All right, if I was able to graph that somewhat well in there I have the cosine graph of negative 3 cosine of x squared. From there, we can go ahead and develop our vertical asymptotes. Those happen everywhere where the graph crosses at 0 because it's undefined at that point for my secant graph. Then from there, it's a matter of drawing their reciprocals. And so my secant graph, -3 secant of x squared, is my blue markings I have on there. And then one complete cycle, I can go from 0 to 4 pi, completes one complete cycle of that particular graph. So have fun as you explore how you can graph all these functions and the variations of them as well.